So in this demonstration, we're going to work with a little bit of the three-dimensional tools that are accessible through ArcGIS. Now, obviously, geography itself is mostly emphasized, and most of this class has emphasized the X and Y position of features on kind of a Cartesian grid or even a spherical surface. But we also do have that vertical axis as well. We've worked with this with the DEMs, we've worked with this with the TINs. And it's nice to be able to visualize these in a way that is three-dimensional, to make use of some of the modern computer technology that we have to render these things virtually in 3 dimensions. So the data that I've provided for you to do this comes from a lot of the other demonstrations that we've done. You don't necessarily have to use the sample data that are in here, and there's quite a lot of them, just to show off a few of these and how they might work in 3 dimensions. But the first thing you're going to do is, as usual, start up ArcGIS. Once you have it loaded, the next thing we want to do is actually leave ArcGIS behind and work with ArcScene. ArcScene is a 2-dimensional or 3-dimensional viewer that kind of doesn't take into account the spherical nature of the Earth in quite so good of a way, or quite so systematic of a way. And that's because it's not designed for things that are on the continental scale, things where it might be really important to see it that way. That's ArcGlobe. You can experiment with that on your own, but that's what you'd want to use for more of a kind of Google Earth feel. Now, to get into ArcScene and ArcGlobe, you can get to them through the Start menu. What I'm going to show you here is getting to them from ArcMap itself. So simply right-click up here someplace, make sure your 3D Analyst toolbar is on. If yours is already on, then don't do this. But if it's not, go ahead and turn it on so it looks like this. If everything is grayed out over here, you would just want to go to Customize, Extensions, and check on 3D Analyst here. Once it's in place, just choose this one over here. This will launch ArcScene for you. There's also launching ArcGlobe if you want to experiment with that later on. But choose ArcScene. What ArcScene is essentially this 3-dimensional viewer. It's fair to think about these things as actually not being totally 3-dimensional, as more being 2.5-dimensional. So a surface will have it'll basically be the surface of something. It would be very, very hard to represent a cave or anything that has multiple z coordinates for a single x and y location within the same layer. So the way we're going to work through these things means we can then drape other layers on top of existing layers. We can extrude things up and down. And we're going to experiment with all of these during this demonstration. There's not a lot of analysis that happens in here, but there is quite a bit of visualization. So once it comes up, just choose Blank Scene here. I know mine's cut off on the bottom here. I'm going to have to move it around just a little bit to conform to the same size window that we've been working with. So just bear with me for 1 second. So you should have something that looks vaguely like ArcMap does. We have our sort of general toolbars across the top. Instead of our table of contents having just layers, we have scene layers, and we have a few other things that may not look as common with navigation. But just as usual, we're going to choose our Add Data. And at this point, you can work either with a TIN or a DEM, anything that has an elevation associated with it. Navigate to your Demo 13 data or your TIN, wherever it may be. If you do bring in a DEM, and I'll demonstrate this in a moment, there's going to be one additional stage that has to happen. But here, go ahead and bring in your TIN. And immediately you should see that it brings it in 3 dimensions. So this first tool, if that's not your default, is Navigate, and that's going to allow us to kind of drag it around. Now, I've already mentioned many times, and it should come to no surprise to anyone that has come to Notre Dame, Northern Indiana is pretty flat. So what we're seeing here is this is it in 3 dimensions, but it only varies a few meters over the entire region that we've been working with. So the fact that it's very, very flat is actually accurate. If you get really in there, you can see that there's a slight difference between the river and what's up over here. So if for some reason your TIN has come in without being able to see elevation here, you can always go into the layer properties just like you would elsewhere in the symbology. You could turn on elevation as you would with a TIN. So if you need to show some other aspect of the TIN, the way you do it is exactly the same as was demonstrated in the module on topography. Otherwise, just for our own gratification and visualization, we may want to go ahead and put in a vertical exaggeration on here. And we do that by double-clicking on scene layers or right-clicking and choosing scene properties. Now in our vertical exaggeration drop-down, we have a lot of different settings. We can decrease it or we can make it up to 10 times. Let's just choose 10 and hit apply. You'll see that it changes it quite a bit. If we come out and choose our full extent, we can now see that over there. So this is 10 times the exaggeration. It gives us a better idea of kind of thinking about what the topography looks like, even if it has been exaggerated. Now your navigation tools, as I already sort of mentioned, are a little bit different than they were in ArcMap. Our full extent is still the same, though it does change the orientation as well. The regular navigation tool will allow you to sort of move yourself around. The mouse wheel zooms you in and out. Right mouse clicking will zoom you in and out as well. Holding down the center button will allow you to kind of pan, and now you have a new axis point. So AXIS, axis point. So that'll let you sort of rotate around an individual point, whatever's in the center of the map. You can also do things like set center on a particular target. So if I click right here, that's now my center point. And if I go back to navigation, I can rotate around that point. Same thing, I could do what's next over here called set an observer. This will zoom to as if I'm standing on the surface looking at from that one particular spot, so I can move myself around a little bit like that. I'm going to go back out to full extent because one of the more fun ones here is this fly tool, this bird tool that you see here. So it's going to say a little bit of description on it. I can hold shift to maintain a constant elevation and press escape at any time to stop movement. But basically what happens is when I first bring it up, you see my bird is sitting on a rock there. I promise you that is supposed to be a rock. And if I click with my left mouse button, it's going to start me flying. If I click, and every time I click, I'm going to go a little bit faster. If I click with my right mouse button, it's going to slow me down a little bit. And this is going to show up in the bottom of the screen over here. I can't gesture to it while I'm actually working flying because I won't be able to do anything but fly. So once I click once, you can see the fly speed in the bottom left there. It's currently 0, so I'm just hovering and sort of moving around as if I was flying. Once I click once, I'm now moving very slowly. Fly speed of 2, 3, 4, 5. I get to 5, I'm going to right click and slow down. And then I can begin to sort of fly interactively through my system here. So I'm flying along the St. Joseph River here with an exaggeration of 10. Feels something like the Grand Canyon or something out of Star Wars. So if I start right clicking, I can go back down to a 0. Once my bird is back sitting on that rock, I can now go back out to all my other tools, navigate, and zoom around. So I encourage you to experiment around a little bit with flying. This will be particularly useful a little later on when we're doing rendering videos from these. So a few of the other things that we can do with the three-dimensional surface is begin to put things on top of them or to deal with other types of layers in 3D. So I'm going to go back into Add Data. And if you remember from one of the earlier ones, we had a series of GPS points. So I'm going to add that in. And these GPS points, if we open up the attribute table, right-click, open up attribute table, have an X and a Y coordinate and then an elevation. So what I want to do is tell the computer to put those things at that elevation point. These are not Z-aware files. It just means that elevation is in there somehow in the actual attribute table. So I'm going to double click on it and I'm going to go over in my layer properties. You see I've suddenly gotten a lot more tabs in my layer properties, including things like base heights, extrusion, rendering, a few other things in here. And I'm going to go to base heights, and I'm going to say down in elevation from features that I have a constant value or expression for elevation, and if I go into the calculator, it is the elevation out of the attribute table. So it's going to go through for each feature, it's going to find what that elevation is, and it's going to put that point up at that location. So that's something that has z-coordinates in it, even if they're not intrinsically part of the file. And what would I do if I had something that was a vector data that didn't have z-coordinates with it? And what I'm going to show here is doing this with the drainage paths. So go ahead and add in Michiana drainage paths from the hydrology demonstration. So you see it's a lot bigger, for one thing, and it's a whole lot of lines, all of which are at 0 right now because there is no elevation associated with them. Now what I can do is to move these up to be on the surface of the tin. So I'm going to go back over to the Base Heights tab in the Layer Properties, and I'm going to choose Floating on a Custom Surface. And the only option I have is that tin Notre Dame. So I'm going to hit Apply, and what you're going to notice is that a lot of them disappear. And that's because anything that doesn't have a base height is just not going to be rendered. So anything that's off of that surface is not being rendered. Oops, it's on the wrong tool there. But anything else has been sort of dragged up and is draped across the surface there. Now in contrast to some of the to get into ArcMap, if I move things around on my table of contents, it doesn't change anything. I can't orient one thing on top of another by dragging it around on the table of contents. I can also work with extruding different layers, so that's sort of stretching them up so that they're a little more visible. If you notice right here, sometimes the drainage paths are kind of lost. The geometry is just such that it overlaps it a little bit. So I'm going to go ahead and extrude one of these up or down. So I'm going to go into Extrusion tab for drainage paths, and I'm going to extrude the features in this layer, and I'm just going to put them up, we'll say 5 meters, and hit Apply. So it'll run in the background, and you see now that lines have become walls. They've been sort of stretched upwards. I could do the same thing with GPS points. So the points then become kind of pillars. If you sort of zoom in on them, you can see that they're kind of pillars pointing up now. Now there's a few other things that I can do in here as well. I put these as just being sort of 5. I could do negative as well if I was really interested in what was happening underneath it. But if I add in one other layer, which is this Notre Dame Castle here, this is a polygon layer, and if we open up the attribute table for it, you'll notice that each one of the features has a height associated with it. So I can actually tell it to extrude it based on that height field. So the first thing I'm going to do is turn off some of these other guys. I'm going to go into the layer properties for my castle. First I'm going to tell it to float it up onto the tin, so the base height is going to be the tin. I'm going to go over to extrusion. I'm going to extrude the features in this layer. I'm going to use that calculator over there to say extrude it up to height. So whatever it is in that field, I'm going to bring it up to that. And what you'll notice is that we now have a castle where some things are extruded up quite a bit, other things are not. So there's a few in there that I left as 0. Those you can extrude up or down as you go. In fact, I can actually do a lot of that even right in here. So there's ones that have a height of 0. I could select them. I could do my field calculator within here, make them 4. And by the time I'm done, they've already been extruded up because it's just looking at those values sort of as it goes. So that's a good way to create kind of simple architectures. Obviously this is sort of a very fancified version of a castle based on the Hesburgh Library here at Notre Dame, where some parts of it have actually been increased in size quite a bit. So if you want to experiment with this, you would do most of the editing of the polygons in ArcMap, and then you would simply bring them over into ArcScene. Now the very last couple of things that I want to show you, first I'm going to just show one other data type, bringing it in. I'm going to turn off everything else that's in here. And you'll notice that I did give you a DEM, and I want to just show you what happens if I bring in a DEM. Now remember when I brought in the tin, it automatically floated it right up to the surface. It had the topography in there accurately. The DEM, the computer has no way to know that that's not just a one-band image, so it doesn't immediately bring it up and create a three-dimensional surface out of it. So to create that three-dimensional surface, I need to go into it, go to base heights, and just set itself as it's floating on a custom surface, and that'll turn it into a three-dimensional surface. So just like the tin, they should look remarkably similar. They actually overlap quite a bit in there. Now, the other thing that you might want to do is to drape one raster layer over one of these things. And I gave you one example of that too, and that's this Notre Dame Landsat. So this is a Landsat image from 2000. It comes in as 0. There's nothing height associated with it. It would be very, very hard to get that up to the level and show it in 3 dimensions unless I go in and float it either over the tin or over the DEM. I'm going to float it over the tin and then turn off the DEM. So now what I have is a 3-dimensional version with an actual surface of it. I can see that sort of library castle where it's supposed to be. In fact, I could change it so that this renders a little bit more cleanly. It's actually downgrading it just to throw it in 3 dimensions. If you ever want to change how precise it looks, it's over in the rendering tab here, and you just are simply going to change it up to be high for the quality enhancement. So that makes it a little bit nicer looking, and I can go ahead and just have that in place, showing me everything in 3D. So one of the neat things about this stuff is you can create an image in 3D, and then you want to get it rendered out into something that you can use in a presentation or a video that you could use online or show to your friends. And we do all that just like we did with 2-dimensional stuff in File. That's going to yell at me briefly. Export scene. Now choose 2D, and this is going to export just basically a screenshot of that one spot. Probably do a JPEG or something like that, and it'll export that one little piece that you see here in the viewer. You could also do the export 3D. The only option that you have in here is what's called a WRL file, VRML. They're not particularly useful in a lot of other 3-dimensional viewing programs, so it's actually quite hard to get these things back out from ArcScene into something like AutoCAD. So be careful with trying to use those for anything other than a visualization. The last thing that's really neat that you can do is actually record videos, and this is probably the most useful part of the 3-dimensional viewers, is that we can go in, and if we right-click up here and choose our animation toolbar, we have the ability to basically open our animation controls and start recording. And this is going to record whatever we view at that moment. So whatever's happening in the image is going to be recorded. So once I hit record, I can go over to my bird tool. I can do a nice little flyby of Library Castle here. Maybe speed it up just a little bit. Go all the way back down to 0. Stop my animation. And now I can just play that back as many times as I want to. If you don't have a steady hand, it might end up being a little bit shaky. There's probably better ways to deal with it. Now once that's done and in place, I can just go into the animation toolbar here, go to Export Animation, spit it out. It's going to only be able to spit it out as an AVI. You could use some other program to convert that into another file format if you needed to. Hit Export. It'll ask for some settings. Then it'll run through that video, taking a certain number of shots and turning it into a video. So I encourage you, while this is happening, don't check your email. Don't load up something private, because there's a fairly decent chance that that'll make it into like a screenshot in the middle of your video. So just let it run as is. Probably don't record very, very long ones, because it'll eat up your computer for a while and make pretty enormous files. So once that's finished going, it's not going to tell you that it's saved, but it has. So now I could easily go to the desktop where I saved mine, load up that new video file, and sure enough, I have a nice little video that I could insert into my assignment or show someone online. So that's really it for the stuff that you might want to do in 3 dimensions using GIS data. Obviously, there's probably quite a bit more that you can do. You can get very, very complicated animations put together. You can control how things are sort of rendered one on top of each other. So if you want to play around with it, please do. And do not hesitate to ask me any questions that you may have. Thank you very much, and have a good day.